Hello class ninth. Today we are going to discuss about matter in our surroundings part 3rd. Students, this is going to be the last and final video of chapter 1 of your science book, that is matter in our surroundings. So in this video we shall discuss about the remaining topics of this chapter, which are sublimation, effect of pressure on the states of matter, evaporation and boiling, and the factors affecting evaporation. So let's take a look on the above said topics, and students kindly listen to it carefully. Only then the topics will be clear to you. So, sublimation. We have always seen that our mothers, they put naphthalene balls whenever she has to keep the winter clothes in bed. Or after the winters are over, whenever she has to fold the winter clothes, she puts naphthalene balls in it. And after 5 to 6 months, when the winters again arrive, we see that the naphthalene balls are gone without leaving any mark or any patch or blotch of liquid on our clothes. So it means the naphthalene balls, which were solid initially, have directly got vaporized. So this direct conversion of solids into gas is known as sublimation. Only those substances whose vapor pressure becomes equal to atmospheric pressure before their melting points arrive are capable of undergoing sublimation. Or we can say those substances whose vapor pressure becomes equal to atmospheric pressure before the melting point or before they get melted, they are only capable of undergoing sublimation. Dry ice, which is solid carbon dioxide, it sublimes at minus 78 degrees Celsius. Some other examples of substances which undergo sublimation are ammonium chloride, camphor, which we use in our daily activities, mostly in religious practices, naphthalene. The balls of naphthalene are used when we pack our winter clothes or when we pack our summer clothes, and when a new season arrives and we pack them for a period of 2 to 3 months or more than that. Apart from that, anthracene, benzoic acid, iodine, etc. also show sublimation. If you want to get a direct example of sublimation in your daily life, you can see the room fresheners or the room fresheners that we use in washrooms. For example, Odonil. It is solid and it is directly getting converted into the gaseous state, and by getting converted into the gaseous state, it spreads the fragrance or the aroma in the whole room. So this is a very common example of sublimation that we observe in our daily life. So we can prove, or we can give a solid proof of sublimation with the help of an experiment. We have to take some camphor or ammonium chloride, we have to crush it down and put it in a china dish. Then we will put an inverted funnel over the china dish, and we will put a cotton plug on the stem of the funnel as it is shown in the figure. We will heat slowly and observe. What you will observe is that the ammonium chloride, which is in solid state in the china dish, it will get vaporized. Since the cotton plug is placed at the stem of the funnel, so the vapors are not allowed to escape. The vapors, they settle down at the sides of the funnel, they stick to it, and when the temperature cools down, the vapors also cool down and they get directly converted from vapor state to the solid state. So conversion of solid directly to vapors and vapors to solid is known as sublimation. It is clear from this experiment. Applications of sublimation. It is useful in purification of solids which sublime on heating and contain non-volatile impurities. So the pure substance, it undergoes sublimation, leaving the impurities behind. In very cold places, snow does not melt but sublime directly to vapors. In frost-free refrigerators, ice on the walls of the freezers sublimes when warm air is circulated through the compartment during the defrost cycle. This can be observed in our homes also, where we are having modern quality frost-free refrigerators. Now coming to the effect of pressure. To convert a gas into liquid or to convert a liquid into solid, interparticle space should be decreased and interparticle force of attraction should be increased. There are two ways in which we can achieve this: by applying pressure or by increasing the temperature. The effect of temperature we have discussed earlier in our second video. So here we will discussing the effect of pressure and how pressure is used to convert liquid into gas. No, not liquid into gas, but gas into liquid, yes, and liquid into solid. By applying the pressure, take a certain volume of gas in a cylinder which is provided with a frictionless moving piston. Now compress the gas by pushing the piston. Consequently, when you apply pressure, the interparticle space gets decreased and the gas particle come close to each other. And when the interparticle space is further decreased, they start attracting one another strongly and the level of attraction becomes equal to that of liquids. In other words, the gas is liquefied by the application of pressure. For example, liquefied petroleum gases which we used for cooking purposes. So here you are having a piston and a cylinder and gas is there. You can see the piston is pushed inwards and the particles of gas they come closer to each other, and the piston is further pushed inwards and pressure becomes so high that the particles are very close to each other, and now the level of attraction and the interparticle space becomes equal to that of liquids, and hence a gas is converted into a liquid. By lowering the temperature, if we cool the gas, the kinetic energy decreases and the particles slow down. As a result, interparticle distance decreases and interparticle force of attraction increases, which pulls the gas particles close to form a liquid. Students, gases like ammonia, sulfur dioxide, carbon dioxide, etc. can be liquefied easily either by applying pressure at room temperature or by cooling at atmospheric pressure. If carbon dioxide is cooled under high pressure, it can be directly converted into solid carbon dioxide, which is also called dry ice. If pressure is decreased to 1 atmosphere, this dry ice sublimes, that is, it directly gets converted to gas. Now the question for you is, why is dry ice called dry? Why the word dry is used with it? Evaporation. Students, it is a surface phenomena. The phenomena of change of liquid into vapors at any temperature below its boiling point is called evaporation. For evaporation, there is no need to achieve the boiling point. So what happens? Particles of liquid are constantly moving. It leads to collision. Due to that collision, particles start moving with different speeds. Thus, they have different kinetic energies. At any given temperature, the kinetic energy of some particles on the surface becomes so high so as to break down the force of attraction. Due to that, the liquid particles leave the surface and gets converted into vapors, and hence some of the liquid particles on the surface gets converted into vapors and vaporization occurs. This process of conversion of liquid into vapors without achieving the boiling point is known as evaporation. Thus, it is a surface phenomena. Now coming to the factors which affect evaporation. First of all, it is the surface area. So students, greater the surface area, more will be the evaporation. Second one is temperature. Higher the temperature, more will be the evaporation. You can easily observe it during the summer season. So in summers, rate of evaporation will always be higher than in winters. Third one is humidity. Humidity infers or refers to the water vapor content present in air. More the humidity, lesser will be the evaporation. That is why clothes get dried easily in summers and it becomes difficult to dry the clothes during monsoon season, because during monsoons the rate of humidity or the level of humidity is very high. Next factor which affects evaporation is speed of wind. More the speed of wind, more will be the evaporation. So on a windy day, clothes get dried faster than in normal day. Next factor which affects evaporation is nature of liquid. Lesser is the boiling point, more is the tendency of the liquid to evaporate. So the force of attraction between the particles of liquid also plays an important role in determining the rate of evaporation. Force of attraction will be less in liquids with low boiling points, so they get easily evaporated. Now, the effect of evaporation. The most common and prominent effect of evaporation is that it causes cooling. Liquid particles have high kinetic energy and they leave the surface and get converted into vapors. As a result, the kinetic energy of the remaining particles of liquid decreases and hence the temperature of the remaining part falls. As a result, evaporation leads to cooling. Example is sprinkling of water on the roof or open ground in summer, pouring of acetone on palm, wearing of cotton clothes in summer, perspiration keeping our body cold, ice rubbed on a burnt part of the skin, and spraying of some ether on skin before performing a minor surgery. All these examples lead us to the inference that evaporation causes cooling. Now, last but not the least, we are coming to the difference between evaporation and boiling. So, evaporation, students, it is a surface phenomena. Boiling is a bulk phenomena. Evaporation, it can occur at any temperature and we do not need to arrive at the boiling point. Boiling, it takes place at a particular temperature when the liquid is heated, and until and unless the boiling point is not achieved, you will not see the conversion of liquid into vapors. Evaporation always causes cooling. No cooling is caused during boiling. Evaporation is a slow process and boiling is a fast process. So this is all about today's lecture. I hope it is clear to all of you. In case you are having any of the doubts, you can paste it or post it in the comment section. Thank you.